clarifier agent, which is a thinker, and it's an expert in what? It's a private member. Okay. We have the think and asynchronously. We put the prompt here. Analyze this idea and break it into tasks. We take the idea that we receive and we put it here. Okay, we put it here, and then we expect it in this format, in the markdown format. And then we await the result, which is task 4, the idea that we have, and these are the tasks. So now implement the actual LLM call. Okay, and we have a cancellation token. Let's see what other agents we have. We have the episode runner, which is the Ralph. And the episode runner has a timeout, max number of turns. And this is what it does. It has a prompt, our working directory, and we're counting. We're waiting for errors, waiting for timeouts. And now this is our watcher. What we're doing here, we're trying to see, we're tracking the cancel. We have an auto cancellation. We're scheduling a cancel operation after the timeout has happened. And then this is the big part. This is the meaty part. We take process start information. We use Claude because we're using Claude, but we can use it for anything. We have the max turns for our working directory. We redirect anything to standard input. Remember here, we have this kind of real-time streaming it. We can stream as JSON. We can do other things. We use shell execute. Okay, so now this is the part I wonder about. So I'm going to copy this. I'm going to paste it here for now. Let it wait. And then we're going to create no window true. And then we receive data or receive errors. We start, and then we wait for the result, and then we do the result here. Okay. Now I want to see our interfaces. For our interfaces, this is our thinker. The CLI agent is responsible for running an episode with a prompt in the working directory, and it is going to do some actions. And we have a state that we sync the state in the working path as long as it's not canceled. Okay. The last step we need to do is our prompt manager. Our prompt manager, we have the prompt. You are an expert C#.NET developer with deep knowledge of the C# language features, the .NET ecosystem, the design patterns, clean architecture. We insert the regression directly and concisely. We have another prompt. We have the requirement. Oh, so we have, let's ask this question. We have the same thing here, clarifier agent. And this is why it's important to look at the code, because now we can ask question. We have a prompt. Okay, so I want to say, I have two questions. First question is about this use shell execute. Second question is about the prompt manager. I see the prompt manager has some prompts, but I also see that the agents have prompts themselves. Can you explain this for me? Okay, so now it's going to do an explanation. And to kind of make things a bit more dynamic, we will introduce another part of our, okay, so we will introduce a little, so remember here, okay, so while this is working, let's read our Reddit thread. So it also said that spec sizing, so we want to leave enough room for implementation with eat loop. If your spec is too bloated, you are risking hitting the dump zone during every single interaction. We also need this bi-directional planning. Have you and Claude both ask each other questions until your spec and implementation are fully in line. This surface implicit assumptions, which are generally the source of most bugs. So we own the spec. Now it has told us that appropriate in two places, single source of truth. We can reference this. So this is why actually I'm going to put this in wisdom. We're going to create a new directory called, let's put it here. We're going to call this wisdom. Okay, we're going to say wisdom. Wisdom.md. Okay, inside of here, I'm going to call it, okay, ideas.md. You could use txt too, but important. It is important to read the code. Read the code, go slow so you can go fast. I think that the more skeptical we are with the agent, the more it is better, because we can still go faster than we could ever imagine, because we can go really fast and then keep going back and forth with the agent, asking it to fix this, fix that, fix this, fix that. Or we can just take the time to walk with it and we'll be faster, I think. All right, that was the wisdom I wanted to share here. Let's go back to our application. Now, the shell execute is going to just, it's input and output, okay? So now, what's next? Well, I am curious about this bi-directional thinking, and we're gonna actually use this as inspiration, the bi-directional planning in fully align. Okay. I'm gonna paste this here because, you know, it's good to use ideas from people smarter than us in that area, because then we don't have to worry about it. So okay, so we want to remove implicit assumptions. I'm thinking my user means an admin. Claude is thinking user means any visitor. My idea of fast is, right? You see what's going on here? So okay, so see, that's the problem with implicit assumptions. The developer, we tell it one thing, it believes something else. Simple CRUD means 4 endpoints. Simple CRUD means 4 endpoints with validation, error handling. Okay, so we're going to say here, okay, so now I think what we should do is, okay, so now our bi-directional planning, instead of one way, we build a CRUD. CRUD makes 50 assumptions and we say that's not what I wanted. You see what's going on? We say that's not what I wanted. So we're going to do this bidirectional planning. The bidirectional planning is that the human builds a CRUD. Claude have questions. What fields are on user? Is off required? Soft delete or hard delete? Human says, well, this is what I need, this is what I need, this is what I need. And Claude said, oh, now here is the plan. We do this, we do that, we do this, we do this, we do this, we do that, we do this, we do that. And human say yes, but also add timestamps. Updates the plan, confirm, and then we build. Now, our I want to change the theme briefly just to see if Claude has some issues. I'm just playing around with the ideas here. Well, we'll use a hacker theme tonight. Okay, I hope it's not too jarring. Okay, so we now have to think about it this way. We have the clarifier. In fact, let's choose another theme because this theme is too. What do you think? This one? You like the dark or light themes? But it's night time, so we'll use the dark theme. I like a light. Okay. So the expert. So now this is the pipeline of our agents, right? In one hand, I think I will do best if I do a MS Paint session. Okay. So we have our, think of our agents here. So we have our agents, we have another agent, we have another agent. And let's assume that we are going that way. We're going that way. We're going that way. Every agent is doing something also along that way, but every agent is also doing something, and then something, and then something. And then we grab all of this information, we package it, and then we package it again until we finish with the final product. So basically, this would be what we'd call, this is one group actually. This is one group. And then they write their thing here. So that's the like the ledger. We can call it like that. And then this is where they write everything, and this is where they read it. So I think this approach of having them receive, then the expert, and then until the loop is finished. So now we need a conversation loop between the clarifier and the expert or the human. So it has written agents again. So let's see what pending changes do we have. We have a ton. Okay. I'm going to say to Claude, hey, I think, okay, let's unpin this. And this is what he has given us. All right. I'm going to say, currently I have 17 files. We don't want our system to get too bloated right now. We're still kind of like in the, we haven't even tested the loop yet. So what are you trying to do here with all these files? So this is how we do it. We do not just jump into the, we do step by step, step by step, step by step. And this is the part, I think that's the clarifier. We say, based on these answers, stay aligned or ask follow-up questions. So let's go into our prompt manager. So we have those two agents here, planning sessions, expert, result. We go into the prompt manager now. This is the prompts that we have. We have the export prompt, the clarifier prompt, and we have the build prompt, which is a bit more complicated. So we say static agents.md for the context project. We're gonna change this to like a better read implementation plan for the full task list. And then the current task is it receives a task and does it. So we give it only one task actually. You see, execute one and one thing, only one task. That way, it is far better. Now we tell it to implement only this task, nothing else. Then we run the verification. If it passes, we mark it. If the verification fails, do not continue to other tasks. Now there's the planner. We have our build task list where we take the idea, we take a task, we join them. We say this implementation is the idea. So you see, this is a form of, this is like a user interface, right? But it's in code. Because sometimes we are too quick. In fact, let's actually go into our wisdom section, and we're gonna say here, we're gonna say we forget that text is also a user interface. We also forget that bloated graphical interfaces are not always the best in all cases. Okay, so that's another entry. All right, so now let's build a new version. Okay, so what did it say? It says what we've built. We have this is the files that we're having here. Hello world. We have interfaces. Is it premature? We have a prompt manager. That's the file writing. We spawn the CLI. Expert agent not needed yet. Planning session not needed yet. Now what we actually need to test the loop, program episode runner. And this is the simplest of tasks. New runner, episode runner. We wait for a result that is the result of an operation that is run when we say hello world and exit. We go into our workspace. We say console write line, write the line, and return the exit code. So that would be a simple text. Well, we actually might need these agents, but I see some other maybe the files. Okay, let's keep things as they are, but let's compose them. Walk me through the workflow of the first idea would be to, okay, let's actually dog food our application. We want to add a simple feature, a simple database, SQLite. And all we do is we can input wisdom. So it's like a wisdom gatherer. We just put wisdom, and you also automatically, based on the content of the wisdom, you will use the prompt manager to apply two prompts. The first prompt is refine, is to refine the idea, correct it for grammar, and the second is to, from the content, create 3 tags that are most appropriate. And those tags, when we retrieve it, we can display it. And it's a nice way to categorize things. We can also retrieve it by tag, a list of items by their tags. That's it. Now we want to implement this with Ralph, our current Ralph implementation. Is it ready for that? We would basically want to use Claude headless with streaming. Okay, let's see. New soundtrack. Okay, so now we have the new workflow. But before we read the new workflow, let's read this comment here. And this user says that the DOM zone is actually real. The DOM zone for the loop, okay? So it is actually a real thing. So how is it constructed? So it says in terms of consensus back after 1,000 tokens, 100,000 tokens, cloud's performance degrades. So we keep our loops and specs lean to avoid it. Second is the slop. So we don't want it to write like, we have to tell it, test the requirements, not the implementation. It's a pattern, not a plugin. Be crystal clear. Do not use the RAF plugin because it... Okay. Now let's check this based on what it says. Currently, it says that we can go like this. We're gonna run Ralph in plan mode. That will generate the implementation plan. Okay. Okay, so I'm gonna do that. I'm gonna do .NET run. So we're gonna see, this is the moment of truth, guys. This is the moment of truth. Let's type .NET run. Let's see. Our project is building and we have an exception. The exception says that Claude, it cannot find the Claude, and I know why. It needs to find it in C. Okay, we're gonna say, do not do anything else. Okay, I know why it's that. Okay, we're going to copy this. It just cannot find the executable. It has tried running it in three loops. So I'm going to go here and says, here is the output. So we got something, right? It has run a number of times. So now we're gonna say it's going to find the executable. So we're gonna say yes. So we're gonna have a fun project in the meantime. And this fun project is going to, we're gonna go into ideas and we're going to, but before we do that, the fun project it's going to be cool. Basically, we're gonna have procedural interfaces. Okay, so we fixed it in Windows, and where did it put it? So now this is the fix. instead of doing this, it uses if it's Windows, it's going to use cmd.exe and call Claude. And then now let's try it. Let's try it. .NET run. Let it run. It's gonna. We expect it to say hello world. We expect it to say hello world. And Claude says hello from Ralph. Hello from Ralph. We got it. This is the moment of truth. Our system is working. That's amazing. This is actually amazing. So our first iteration, we're gonna call this, we're gonna say Eureka. Let's say Eureka. Or it's alive. It's alive. This might be boring to some people, but we're actually doing some real science, kind of scientific thinking here. Okay. All right. So as customary, it worked. We got hello from Ralph. So here we need a checkpoint. Can you give me a summary of what we've done that put us at this stage? We also want to put pitfalls we've encountered along the way and wisdom we've gathered. And I think that would be a nice change log. So we create a change log, which is like a historical, it's like for posterity. You know, we can add more and more entries. We just created the coolest thing here. Read it, what has it done. I guess we're gonna target I would say yeah, 55% change log so far. The first successful episode, visualize the console application. have lift up. We have fellow from route. Okay. So next step. After this step, what do we do? Not only this step, let's go proper we have to debug this. We have to our application. The documentation is like this a document where we can actually, when we launch a new session here, we have all the info. We pick up so now it's gonna create a new this is kind of like the entry point. Let's check that. Save.net run. Answer. It took us 9 seconds to get the answer. Ding ding dong dong, bom 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 bow. Ding ding dong. So.
Frère Jacques, frère Jacques.
Here is the setup. Write the agents, the spec, initial implementation. We have the plan mode. So see, the state sync does this, route does this, route does this. Now, I want to see, is this accurate? So do we run around mode here at this point right now, or do we have to kick start it with like a prompt or something? Let's see. Because like we're learning. To buy an idea, so you spec line and the line spec file, or can I make a line prompt? So let's see. So we have a spec file for us. Let's see. Uploaded our program file. Let's see what the program file looks like. Program file tells us that our implementation get the implementation. Let's see if that works. Going to type is unimplemented. So it says he's created the implementation. Created the implementation plan as follows. Okay, so I'm going to do not implement anything plan only. Okay, so I'm going to say here is the output I've got, and I've also noticed that we need a little animation, like we need a duration and also some spinner. Is that possible to do while we're waiting for it? Maybe that would be a little add a touch of dynamism. My goal would be like we have a timer, but also a little kind of almost like a little dot that moves from left to right that leaves a little trail, and we would go back and start it with some right. I don't know if I said animation. have another animation in this video. Snap turn. Okay. So so now the next task. We read agents, read the spec, we analyze, we generate the it's too low for the terminal. So we have to let's start it over. side as well. Okay, so now let's check. Did we also have the feeling as I think that's a good. Okay, now we have to look at okay, we can use what do you recommend? We use Python or we use C sharp for those forms? Which one are you more trained on? Python will use a virtual environment, C sharp. We run the plan. Right there. So now, you see that little animation we added? So now we have our CLI agent. So they're working. Kind of talked about this stream of thought coding instead of vibe coding. What does that mean? So now it's more like we are building things and then it's showing us the code it's about to build. It's almost like, think of it like a editor, but a smart editor. You see the code, you see the plan. It stops. You see, we're architecting it at the function level. And then it's ready, it builds it for us. Moves on to the next stage, builds it for us. we can stop and possibly ask it questions at that level of coding before it commits to it, and that way it's giving us a lot of context. It's showing us what files it's related to it, so it's kind of teaching us about the code base as we're moving forward. I think it's a nice in-between step between vibe coding where we're just typing stuff and let it rip and then come back and let it correct it and bring tokens. That's the wisdom I've discovered. I think we can refine that idea a little bit more. Okay, one task complete. Build succeeded. Task not completed annotation. Okay, so my thought, I would say, let's see. Got that wrong. Okay. Finally, extract file. Okay. Exit code. Got that wrong. We build. We added the packages. My understanding was that it would go to the next part of the plan. Do we only have one item on the plan? And also our context is about to finish. Could you kind of, in our changelog, in our knowledge base as well, kind of give us a summary, a quick update about where we are, what we've built? I think we can have a more appealing name for that. But also we'll have to also think about an interface. In fact, could you show me an interface, like a mock-up user interface for that type of programming that we're talking about? Non-issues. Okay, copy. We're gonna start a new chat. I don't like when it compacts. If it compacts, it's gonna degrade. So I'm gonna copy. I'm gonna paste this. We're gonna continue. Let's read our changelog for successful episode. I would tell it. I want to make some instructions in our changelog. Strategy is to have it show the latest at the top. Second part is also maybe if you can have the time as well. Okay. Now let's see what our agent is building. Let's see, yes, close, and then we're gonna see
1. Why this step? Ralph explains his reasoning before writing code. You understand the architecture as it forms. 2. Related files. Shows what exists, green, versus what will be created, yellow. You see the blast radius before approving. 3. Code preview. The exact code about to be written. No surprises. 4. Action bar. Ask a question, pause and clarify. Reject and revise, try a different approach. Approve and build, looks good, do it. The token economics. Vibe coding burns tokens on. Building wrong things. Explaining what it built. Fixing misunderstandings. Rebuilding. Stream of thought spends tokens on. Explaining intent once, upfront. Smaller implementation units. Fewer corrections. With vibe coding, you often end up with working code you don't understand. You're a stranger in your own repo. Keeps you co-located with the architecture. Every function exists because you saw it proposed and nodded. With vibe coding, you often end up with working code you don't understand. You're a stranger in your own repo. Stream of thought keeps you co-located with the architecture. Every function exists because you saw it proposed and nodded. With vibe coding, you often end up with working code you don't understand. You're a stranger in your own repo. Stream of thought keeps you co-located with the architecture. Every function exists because you saw it proposed and nodded. With vibe coding, you often end up with working code you don't understand. You're a stranger in your own repo. Stream of thought keeps you co-located with the architecture. Every function exists because you saw it proposed and nodded. With vibe coding, you often end up with working code you don't understand. You're a stranger in your own repo. Stream of thought keeps you co-located with the architecture. Every function exists because you saw it proposed and nodded. With vibe coding, you often end up with working code you don't understand. You're a stranger in your own repo. Stream of thought keeps you co-located with the architecture. Every function exists because you saw it proposed and nodded. With vibe coding, you often end up with working code you don't understand. You're a stranger in your own repo. Stream of thought keeps you co-located with the architecture. Every function exists because you saw it proposed and nodded. The flow. See plan, see proposal, ask questions, approve, watch, build, next step. Each approval is a checkpoint. You're never more than one function away from understanding what happened. With vibe coding, you often end up with working code you don't understand. You're a stranger in your own repo. Stream of thought keeps you co-located with the architecture. Every function exists because you saw it proposed and nodded. The flow. See plan, see proposal, ask questions, approve, watch, build, next step. Each approval is a checkpoint. You're never more than one function away from understanding what happened. With vibe coding, you often end up with working code you don't understand. You're a stranger in your own repo. Stream of thought keeps you co-located with the architecture. Every function exists because you saw it proposed and nodded. The flow. See plan, see proposal, ask questions, approve, watch, build, next step. Each approval is a checkpoint. You're never more than one function away from understanding what happened. With vibe coding, you The hottest AI coding take, your agent should be stupid.
The hottest AI coding take, your agent should be stupid. We're live coding the Ralph pattern, an architecture where the AI has no persistent memory, no grand context window, no delusions of understanding your entire code base. It wakes up, reads a markdown file, does exactly one thing, and dies. C# from scratch. Process.Start, energy. This is how you actually ship with AI. The hottest AI coding take, your agent should be stupid. We're live coding the Ralph pattern, an architecture where the AI has no persistent memory, no grand context window, no delusions of understanding your entire code base. It wakes up, reads a markdown file, does exactly one thing, and dies. C# from scratch. Process.Start, energy. This is how you actually ship with AI. The hottest AI coding take, your agent should be stupid. We're live coding the Ralph pattern, an architecture where the AI has no persistent memory, no grand context window, no delusions of understanding your entire code base. It wakes up, reads a markdown file, does exactly one thing, and dies. C# from scratch. Process.Start, energy. This is how you actually ship with AI. The hottest AI coding take, your agent should be stupid. We're live coding the Ralph pattern, an architecture where the AI has no persistent memory, no grand context window, no delusions of understanding your entire code base. It wakes up, reads a markdown file, does exactly one thing, and dies. C# from scratch. Process.Start, energy. This is how you actually ship with AI. What if the secret to reliable AI coding isn't making agents smarter, but dumber? Join us as we build the Ralph pattern from scratch in C#, an architecture where your AI agent wakes up, does one task, forgets everything, and repeats. No hallucinations. No context window disasters. Just a simple worker bee that follows the plan on disk. We're vibe coding this live, blank project working agent loop. The hottest AI coding take, your agent should be stupid. We're live coding the Ralph pattern, an architecture where the AI has no
Traditional AI assistants try to be geniuses, holding entire projects in memory.
Traditional AI assistants try to be geniuses, holding entire projects in memory until they inevitably hallucinate. We're taking a different approach. Today we're implementing the Ralph pattern in C#, a dual-brain architecture that separates thinking, API, from doing, CLI. The secret? Our coding agent has no memory. Every episode starts fresh. The file system is the only truth. Live coding from first principles. No frameworks. Just system, diagnostics, process and a dream. Traditional AI assistants try to be geniuses, holding entire projects in memory until they inevitably hallucinate. We're taking a different approach. Today we're implementing the Ralph pattern in C#, a dual-brain architecture that separates thinking, API, from doing, CLI. The secret? Our coding agent has no memory. Every episode starts fresh. The file system is the only truth. Live coding from first principles. No frameworks. Just system, diagnostics, process and a dream. Software development isn't a chat session, it's a manufacturing pipeline. We're building Vibespecta's core engine live, a clean room where AI thinks, a dirty workshop where AI codes, and a dumb little worker named Ralph who reads his instructions from a markdown file, does the job, and goes to sleep forever. Dual brain architecture. Episodic execution. Zero hallucinations. Let's vibe. Traditional AI assistants try to be geniuses, holding entire projects in memory until they inevitably hallucinate. We're taking a different approach. Today we're implementing the Ralph pattern in C#, a dual-brain architecture that separates thinking, API, from doing, CLI. The secret? Our coding agent has no memory. Every episode starts fresh. The file system is the only truth. Live coding from first principles. No frameworks. Just system, diagnostics, process and a dream. Software development isn't a chat session, it's a manufacturing pipeline. We're building Vibespecta's core engine live, a clean room where AI thinks, a dirty workshop where AI codes, and a dumb little worker named Ralph who reads his instructions from a markdown file, does the job, and goes. Traditional AI assistants try to be geniuses, holding entire projects in memory until they inevitably hallucinate. We're taking a different approach. Today we're implementing the Ralph pattern in C#, a dual-brain architecture that separates thinking, API, from doing, CLI. The secret? Our coding agent has no memory. Every episode starts fresh. The file system is the only truth. Live coding from first principles. No frameworks. Just system, diagnostics, process and a dream. Hashtag wisdom gathered. Don't do Ralph's thinking for him. StateSync provides context, agents.md, specs. Ralph generates the plan, implementation_plan.md. If you pre-create the output file, you've removed the thinking from the doer. Software development isn't a chat session, it's a manufacturing pipeline. We're building Vibespecta's core engine live, a clean room where AI thinks, a dirty workshop where AI codes, and a dumb little worker named Ralph who reads his instructions from a markdown file, does the job, and goes to sleep forever. Dual brain architecture. Episodic execution. Zero hallucinations. Let's vibe. Traditional AI assistants try to be geniuses, holding entire projects in memory until they inevitably hallucinate. We're taking a different approach. Today we're implementing the Ralph pattern in C#, a dual-brain architecture that separates thinking, API, from doing, CLI. The secret? Our coding agent has no memory. Every episode starts fresh. The file system is the only truth. Live coding from first principles. No frameworks. Just system, diagnostics, process and a dream. Hashtag Traditional AI assistants try to be geniuses, holding entire projects in memory until they inevitably hallucinate. We're taking a different approach.
Hello, this is a preview of my voice. Ralph Sharp Loop Implementation.
Hello, this is a preview of my voice. Ralph Sharp Loop Implementation. Purpose: implement the core Ralph Wiggum loop pattern, an episodic AI agent that plans then builds. The core idea: Ralph is a dumb, episodic worker. Wakes up with zero memory. Reads state from files on disk. Does one task. Dies. Loop restarts fresh. This prevents context drift and token bloat. 2 modes. Mode: what it does output. Plan analyzes specs. Generates task list implementation _plan.md. Ralph Sharp Loop Implementation. Purpose: implement the core Ralph Wiggum loop pattern, an episodic AI agent that plans then builds. The core idea: Ralph is a dumb, episodic worker. Wakes up with zero memory. Reads state from files on disk. Does one task. Dies. Loop restarts fresh. This prevents context drift and token bloat. 2 modes. Mode: what it does output. Plan analyzes specs. Generates task list implementation. Ralph Sharp Loop Implementation. Purpose: implement the core Ralph Wiggum loop pattern, an episodic AI agent that plans then builds. The core idea: Ralph is a dumb, episodic worker. Wakes up with zero memory. Reads state from files on disk. Does one task. Dies. Loop restarts fresh. This prevents context drift and token bloat. 2 modes. Mode: what it does output. Plan analyzes. Ralph Sharp Loop Implementation. Purpose: implement the core Ralph Wiggum loop pattern, an episodic AI agent that plans then builds. The core idea: Ralph is a dumb, episodic worker. Wakes up with zero memory. Reads state from files on disk. Does one task. Dies. Loop restarts fresh. This prevents context drift and token bloat. 2 modes. Mode: what it does output. Plan